Thank you very much for the kind introduction and the invitation to speak here. Yeah, I'm Joe Briscoe. I'm the founder and CEO of AeroSolar. I'm also a professor of energy materials and devices at Queen Mary University of London, which is where we spun out AeroSolar in 2022. And really in the first stages of AeroSolar, in the early days, we were working on R&D, development of the process, and initial scale-up to the levels that we could start working with customers. And now we've really transitioned to focus on customer engagement. We're particularly focusing on tandem perovskite technologies, but we are open to work with others. And obviously, I'm going to tell you more about the process and what we do. And I'm also going to share some of those customer engagement outputs, and they've been going really well. And we're particularly focused on the US at the moment. But again, we're happy to work with many companies. So to understand about that, I obviously need to tell you about what we do. But first of all, I'm going to make some statements that I hope are not controversial, and we've seen these kind of things said many times at this conference. Now we are really focusing on scaling up perovskite and getting performance, durability, and yield consistently is hard. I really want to thank Max. I don't know if Max from Swift is in the room, for his lovely graph. Thanks, Max, for your graph, perfectly showed exactly the point that we want to make, is that to get your combination of all of your factors working at production scale is extremely hard. You have to tune all of your processes very carefully to get everything to work. And then something happens, you go slightly out of that really fine tuning, and then everything goes wrong. You have to go back to R&D to find out what was going wrong, or you can use some nice data systems to find out what was going wrong. So it's very hard to get your perovskite consistently produced at scale. And this is delaying the time to market of all of these wonderful companies that we've heard from today and all those others that are out there. So what can we do about it? What can we do about it at AeroSolar? So we've solved this problem using aerosol-assisted annealing of the perovskite films. So this comes in as a step directly following the perovskite deposition. And I'll tell you more about exactly how this works in a second. But what it does is it restores the intrinsic quality of the perovskite materials. When I say intrinsic quality, I mean where the perovskite should be if we don't have those defects that come in from manufacturing. We enhance the crystallization of the perovskite. And importantly, this also improves the consistency. So we can, and I'll again show you some data about this, we can take the variability of the process you naturally get from manufacturing, particularly at scale, and really bring down that variability by bringing up the perovskite to its best quality. Importantly as well, if you saw right at the beginning, we state that it is universal, our process is universal. This applies to all perovskite chemistries. We've demonstrated this on pretty much every perovskite chemistry that's out there. And early days, we published work on this, and now we're working with many different manufacturers, and we've found it works on every different chemistry, process type, different stacks. So it is truly universal. And by enabling us to come and help you and put our process in directly after your perovskite deposition, this means that we can widen your production window. You can not worry quite so much about tuning those parameters really finely. We can allow you to kind of widen that production window, and then we can come in and improve that quality. This, we hope, will accelerate your time to market, and that's the kind of idealistic hat rather than the commercial hat that drives me to make this company and this process a success, is because we really want to assist you in bringing perovskite to market more quickly. So how does this work? This process grew out of our previous work that comes from aerosol-assisted chemical vapor deposition. So it is a chemical vapor deposition related process. And the really important thing from this is that we design all of our tools and all of our systems to deliver a laminar flow of an aerosol, which either can be just a solvent. Our early work was just on pure solvents. But now we tend more to work with solvent-additive combinations. And what's really important about the laminar flow is that we induce this aerodynamic boundary layer across